Good day and hello everyone. My name is Yashlin, matrix number AA2040. Today, me and my teammates are here to explain about the experiment we made from course title Engineering Laboratory 2 DAM14101, Experiment 5, which is Impact Test. Today, I am here to talk to you about the additional theory. The impact test is used to learn the toughness of a material. Toughness is defined as the ability of material to absorb energy and deform plastically before fracturing. Toughness is related to ductility and strength of materials. Since ductility is the amount of plastic deformation that occurs before fracture and strength is the stress needed to cause fracture, toughness is related to both. For impact test, a pendulum is needed to swing from fixed height and strike the standard impact specimen as it is able to deliver sudden and dynamic contact to the load. There are two types of method to place the specimens named IZ test and Charpy test. For IZ test, specimen is faced vertically into the pendulum, while in Charpy test it is faced horizontally. IZ test only has V notch, but in Charpy test has both U notch and V notch. Charpy is common in testing brittleness and the impact strength of a material. Next, I am going to talk about the objectives for the experiment. The first one is to learn whether temperature can make any effect to the impact energy. Secondly, to understand fracture toughness. And lastly, to investigate the relationship between the notch bar impact work and the notch shape. That's all from me. Thank you. Now I pass it on to the next presenter.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Wanzur Aizat Rifki Bawan Azmi, number matrix AA200424. Okay, today I want to present about apparatus and procedure about this project. Okay, firstly, apparatus is one Charpy impact machine. Number 2, specimen, resin plastic, and number 3, stationery. Okay, then I want to present about procedure about this project. Okay, first we prepare the apparatus and make sure they in good condition. Okay, number 2 is then we make sure that the Charpy impact machine is ready condition. Okay, next we take measure of the specimen. The measure needed was in the 5.5 result chapter. After that, we put the specimen in the Charpy impact machine to start the impact test. Okay, after that, after the impact test done, the Charpy impact machine will show some calculation from the impact test. Okay, lastly, we need to calculate the impact strength of the specimen. Okay, that's all from me. Thank you.
My name is Umesh Anak Laki Karunaharan, matrix number AA200258, and today I'm going to be explaining about the result and observation of our experiment, which is the impact test. For the results, you can see there is a picture of the specimen that is attached here. We actually took the measurement starting from the void line to actually measure the fracture length and width. So the data we measured, we actually recorded them in a table that is also provided. The table consists of several types of data, which is the length of fracture, the width of fracture, area of fracture, impact energy, absorbed energy, and the impact strength. We're moving on to observations. Based on the results before, we can observe that the specimen has undergone fracture from the impact test. So we use a 15 centimeter ruler to measure the fracture and then convert it to millimeters. What we got, the fracture length is actually 6.5 millimeter and the fracture width is 10.16 millimeter. The area of fracture is actually 66.960 millimeter square. Impact energy is 0.072 joules and the absorbed energy is 0.150 kilojoules. There is a slight difference in the value observed due to the occurrence of energy loss in the surrounding. Hi, now the discussions. Number 1. What is the value of impact energy in joules for the materials being tested? So we found out that the impact energy for material is 0.072 joules. How we found this out is when the specimen is actually hit by the striker, it absorbs energy until it begins to generate. At this point, the specimen begins to plastically deform at the notch. Fracture, however, begins to occur when the specimen cannot absorb any more energy. However, we compare the height of striker that would have potentially risen in the absence of the striker that actually rises. This is done in order for us to calculate the energy. Number 2, we will be calculating the impact strength in units of kilojoule per millimeter square of the material. So as you can see, the working is actually very short, which means the impact energy equals to absorbed energy over the fracture area. So impact energy is 0.15 kilojoules and the fracture area is actually 0.06 meter square. We convert the unit of meter square into millimeter square and we sub in the values and we divide them. So finally we get 2.26 kilojoules per millimeter square as the final value. Number 3. What are the factors that affect the energy of impact? Temperature and strain rate. So most of the impact energy is actually absorbed by plastic deformation. Ductility of materials such as strain rate and temperature affect the impact energy and the yield behavior of the specimen. This type of behavior is actually noticeable with a body-centered cubic structure material, where lowering the temperature reduces the ductility of the specimen.
Greetings, my name is Tanish Kumar Piran, metric number AA200495. Today I will continue the explanation for number 4 and also number 5. So first off, impact test is actually used in the study of material toughness. So material toughness is basically a factor of the ability of a material to absorb the energy during the process of plastic deformation. So brittle materials will have a much lower toughness as they can only endure a small amount of plastic. The impact energy of materials are lower when the temperature is decreased. This impact test will also be used to determine the ability of a material to absorb energy during a collision. Next, for number 5, some metals are found to be brittle when in much lower temperatures compared to their ductile presence in room temperature. However, the transition from ductile to brittle is actually based on the composition of the metal. A common example that is commonly used is steel. So when we look at steel transition temperatures can be as low as 0 degrees Celsius. So therefore, some steel structures are likely to become more brittle in winter conditions. At higher temperatures, there is adequate nuclear power in the crystal structure to aid the movement disengagements under a remotely applied pressure. So in contrast, plastic deformation of brittle materials can be barely observed. So to conclude all of this, impact is the testing measure of the hardness of a material to determine the ability to withstand energy during the process of plastic deformation. So toughness is about strength and also ductility of a material. The impact value is influenced by the temperature, scale, and also the amount of plastic deformation it endures. So we can improve this impact strength by using polymer blending, and the general modifications that are done is actually using rubber. So that is all from me. Thank you very much.